Welcome everyone. I want to present my paper, How Not to Handle Keys, Timing Attacks on the FIDO Authenticator Privacy. My name is Michael Kemkowski and I am a PhD student at Macquarie University, and together with my colleagues, Dr. Jan Wood and Professor Dali Kafar, and also in collaboration with Dr. Lucian Hansling from CISPA Security Center in Germany, we found out the privacy issue in the FIDO protocol, or actually in the authenticators. So quickly about the modern authentication and where we at in terms of FIDO. So 2012 FIDO Alliance were established and they created first version, but only 2019 when the web authentication protocol was defined, it became to be a popular solution, and currently on the right hand side you can see the Microsoft recommendation where the FIDO key is in the best column on the passwordless authentication. So quickly about the FIDO. So this is really a simple protocol challenge and response. So on the top you can see this black diagram. Number one, number two is the request that user does to the server. Server responds with the challenge, which is forwarded to the authenticator, and authenticator signs it and sends back the signature, which is verified by the server against the pre-registered public key. So FIDO can work as a 2FA, but also as a passwordless flow. But today we are going to talk about the 2FA flow. Some advantages of the FIDO: it is phishing resistant, and it provides device attestation, and also provides the user presence and verification checks. So before signing the challenge, user needs to provide user presence proof, which is basically pressing the button, or verification, which for example can be fingerprint scan. And in our case, the most important part is privacy preserving features that I'm going to talk about later. I want to also mention the certification. So there is a FIDO Alliance certification. Some tokens like Ubico are certified with FIPS specification, and FIDO tokens can be at level 3, assurance level 3 from NIST specification. And in terms of support, we have the support of all the major operating systems and browsers. So quickly about this certification. So FIDO Alliance provide voluntary certification, 3 levels. However, what is important, on level 3 provides the tests and penetration testing of the tokens. So unfortunately, the level 3 is not used yet. So all the tokens that are on the market are either level 1, majority of them, or level 2. So basically they are not checked against side channel vulnerabilities. So about the privacy of the FIDO, on the right side you have like example of our registered authenticator. So let's say that John is registered in service A and service B, and service A generates the token for service A generates one set of keys, so these purple ones, and for the service B, second set of the keys is generated. And each authentication is random, has random challenge. And there is also something called key handles, which identifies the key, but again, this is random and should not be possible to link. And the linking question here is that if purple and green belongs to the same person. And the consequences of breaking obviously can be just targeted recommendations or advertising. However, it can be also more serious, like malicious actors, criminals, or state actors can target individuals. And to support this, I'm giving you two examples. First one is that the FIDO was used to empower at-risk individuals like journalists. 2021, big companies, Microsoft, Ubico, Google deployed 35,000 keys. And also the recent conflict in Ukraine, the FIDO was used to secure their cyberspace. Regarding the key handles, because we use them to execute our attack, these are these randomized identifiers of the keys. They are generated during the registration together with the public key. And sometimes authenticators use them to implement non-resident keys. Non-resident keys means that the private key isn't saved on the authenticator, but it is sent to the relying party, and then it is somehow generated on the fly during the authentication. And it is done because authenticators have the limited space. And these mechanisms can be implemented by simple key wrapping, which means encryption. It can be the key derivation function, so key handle is just the input. And it can be simple reference. And second feature that we use is silent authentication. So on the low level of the FIDO protocol, we have the setup, which is like a binary protocol to talk to the authenticator. And it allows silent authentication, which means that user presence is not required. So user doesn't know that the authentication happened. And this is used by clients to enumerate which key to use. And usually it is not limited, only Windows. We found that only Windows implemented the limitations on the number of silent authentications. And here going to our attack, so this is high level of the attack. So let's say that attacker, for example, malicious FIDO server has a key handle B and key handle A. And it knows about the key handle A, but it doesn't know about who is the owner of the key handle B. So it sends the specially crafted list. It is called allow credential list. And inside this list, we have the multiplication of the key handle B. And what happens in the client is that silent authentications are executed on every single one key in the list. And what we want to achieve here is that we want to check if the processing time of the key handle B is different from the random key handle. And we suspect that if this key belongs to this token, it might be different time. And actually, we identified not only that malicious FIDO server can be our adversary, but also other identity provider, FIDO 2 as a service provider. It can be something in between, like proxy services or something that injects the malicious code. Regarding our experiment, so we took eight roaming hardware authenticators. You can see 7 of them on the picture. Only the Google Titan is missing. We executed silent authentication measurements. We checked 6 browsers on 5 platforms. We did the deep inspection of USB packets. We did a simple study to check the user presence timing. And we did also describe the audio variation of the attack. And we did the FIDO in the wild crawling. And the results are that 2 of those tokens were vulnerable. Silent authentications are used in the browsers. User presence delay is quite easy to mitigate. And the crawling showed that 2FA is the most popular way of deployment. And these are the results. On the left, you can see HyperFIDO and Phaetian. So these are results from the silent authentications. You can see that for HyperFIDO, the difference is 10 milliseconds for one silent authentication, and for Phaetian is 2 milliseconds. And on the right, you can see the diagram that shows how many handles you need to send in the allow credential list to minimize the error rate. And we also applied this delay from the user presence study. And now in terms of the mitigation, so obviously it should be fixed on the authenticator side. However, the problem is that they do not allow firmware update. So only new authenticators can implement, for example, constant time execution or changing the function of getting the keys. And second option is on the existing deployments. It can be changed to the resident keys. However, this is problematic because users need to re-register. And the easiest option is to implement mitigations on the client side, which are basically the limitations of the allow credential list. So something like the duplication or limiting the size or basically delaying the silent authentication would solve this issue. We notified the vendors from Google Chromium team. We received the CVE and they fixed this issue. The same happened for Firefox. We notified Safari, however, we didn't receive the response. The HyperFIDO sent us new tokens to test, and we are testing them. And Phaetian, we haven't received anything. So to sum up, the commercial authenticators are not checked against side channel vulnerabilities unless the vendors do the checks themselves. And the certification from FIDO Alliance only on level 3 checks the penetration testing of tokens. However, as you could see, there is no tokens on level 3. And the vulnerabilities that we found and features that we found: silent authentication, which is dangerous, setup flow, allow credential list that was not limited, and obviously the time differences in processing of the vulnerable tokens. And everything together gave us a nice remote vector of attack to link the accounts of the users. Thank you, and I can take some questions.